InfiniBand is king when it comes to AI, but there's a new challenger on the horizon. Ultra Ethernet is poised to take the crown. Or is it? Does it have what it takes to unseat the incumbent? Or are there going to be challenges that we can't foresee? Join us on this episode of the On-Premise IT Podcast as we discuss whether or not Ethernet will unseat InfiniBand for AI networking in 2024. Welcome to the On-Premise IT Podcast, the only podcast that dares to be both on topic and on location. My name is Tom Hollingsworth, and as a part of Gestalt IT, each episode I get to bring you the perspectives and opinions of a group of IT luminaries, real experts in their field, on a variety of technical topics. Before we jump into the premise for today's episode, I would like to introduce our panel, starting with Jody.
Hi, I'm Jody Lemoine. I'm an independent networking consultant in the Niagara region of Canada. I can be reached on Twitter at @ghostinthenet. I can be reached on Mastodon at @ghostinthenet @hachyderm.io.
Hi, I'm Chris Grundemann. I am an entrepreneur and consultant in the networking and automation space. I can be reached most places at Chris Grundemann, including chrisgrundemann.com.
Hello, my name is David Peñaloza. I'm a consultant for enterprise and service providers, and I can be reached over, Twitter at David Samuel PS.
All right. Well, thank you all for joining us for this episode. Let's jump into the premise. You may not know a lot about AI networking, but you probably assume that it works a lot like the regular network. You'd be wrong, though. There are some very specialized systems that run in an AI network. Sure, the packets are probably going to be delivered to those clusters through good old-fashioned Ethernet, but everything behind the scenes runs on InfiniBand. If you're not familiar with InfiniBand, don't worry, we'll get into the details pretty soon. However, there is a concerted effort in the industry to displace InfiniBand and move everything over to our trusted friend Ethernet. But will it succeed? Because the premise for this episode is that Ethernet will not replace InfiniBand for AI networking in 2024. So I'm going to jump in and kind of open the floor up for our experts here. What do you think about this dichotomy of Ethernet versus InfiniBand for these high-performance workloads?
Well, it's coming from two different perspectives. In a lot of ways, it's like the voice guys coming into data networking and the data networking guys coming into voice. They each have their own approach to things that don't necessarily relate to the others. InfiniBand has traditionally been the go-to for all high-performance computing applications. And, nothing says high-performance computing application like AI. So that's where it was born. And the folks who want things to go Ethernet, well, they're the guys who are coming from the networking side. They know their Ethernet really well. They don't understand InfiniBand at all because that's totally new to them. But who's going to rule the roost here?
And so everyone at the home is clear, yes, historically, because most AI workloads run on HPC clusters, the preferred method for connecting all of this hardware has been InfiniBand. And InfiniBand does not use TCP, it uses RDMA. It's a lot more deterministic. It's a lot more suited for these larger workloads that have very specific performance characteristics. But it's also expensive. And that's one of the arguments that we're getting from organizations like Broadcom, Cisco, the Ultra Ethernet Consortium, Intel, is that tried and true Ethernet performs roughly the same, if not a little bit better, but is significantly cheaper. So is there value in adding these cheaper protocols?
Yeah, I think so, Tom. Some of the advantages that InfiniBand had historically, I guess we'll call it, have started to go away a little bit, right? One of the big things was InfiniBand has historically been a little bit faster than Ethernet, right? You saw 40 gig and comparable in InfiniBand quite a bit before you saw 40 gig come out in Ethernet. Now that, Ethernet's kind of caught up to 100 gig and actually the 400 gig mark seems to be where they seem to be a little bit more neck and neck. InfiniBand had 400 gig capabilities way before we had that in Ethernet. But now it seems that, 400 gig Ethernet is fairly reliable. And so that, just raw bandwidth advantage seems to have gone away. Now, of course, InfiniBand could make another leap forward. But as you said, with the costs, there's a lot of interesting ways to use Ethernet, especially in an IP network. We've done this in lots of other areas where we've moved to these kind of clause-based leaf spine architectures where you build in redundancy and super high bandwidth links, and you can actually double and triple and quadruple 400 gig links to provide terabits of capacity over Ethernet fairly easily. Of course, you've still got to weigh that against these, serial data transmission that's a little bit different than what you might normally see in Ethernet. But I think, between the use of, UDP strategically and other transmission protocols, and also timing protocols, Ethernet, bang for bit, I guess we'll call it, is got to be right up there with InfiniBand at this point, maybe even surpassing it if you really step back and take a closer look.
Chris, I think you're right. And that is one of the goals of the Ultra Ethernet Consortium, is to show that performance-wise, Ethernet has similar, if not increased performance over InfiniBand. Now, to make sure that we're all on the same page here, there's two different networks that we're discussing. There is the traditional network that delivers packets to the clusters, and there is also the backbone, if you want to call it that, between the GPUs that is communicating, and that historically has used a lot of InfiniBand and RDMA and things like that. But we've been trying to get RDMA to run over Ethernet for years. I mean, anybody who's ever heard of Rocky, RDMA over converged Ethernet, will know that. But that sounds an awful lot like some other high-performance proprietary networking protocol that we try to get to run over Ethernet. Fibre Channel, that's right. And I don't remember Fibre Channel being seriously displaced in, no matter how many times people tried to convince me that Ethernet was the way. So do we feel like InfiniBand maybe along that same line of maybe some people will ditch it, but by and large, the people who need the performance will leave it there?
I guess it all depends on in which way things get implemented after this, right? Because if you try to move the needle, in the direction of Ethernet, then is everybody going to create their own proprietary implementation? So my implementation of this is better than yours, and then we'll start having this type of competition. That could also lead then to a higher rate of innovation, but is that where you want to go though? Because then you have to pick between this and this and this other vendor, which again, when talking about competition and price, then might be more convenient than just relying on a single vendor or a single implementation for everything. So it all depends on what's the agreement. But I think that moving towards Ethernet at least is gonna widen up the implementation spectrum that you could have, rather than just having this specific way of doing it and sticking to it.
So let me play devil's advocate for a minute, David, because if you're using InfiniBand, you are using a single source vendor. You're using NVIDIA because they're the only people that really control the InfiniBand spec right now through their acquisition of Mellanox. So is it better to rely on one vendor who has, tried and true performance? Or is it better to say, I would prefer to take my chances with a different vendor, although yes, the Ultra Ethernet Consortium was founded to ensure that there is interoperability between all these standards from Cisco, Intel, Broadcom, any of the major networking manufacturers. Are you willing to trade a tight-fisted grip on the protocol with proven performance for a toss-up, basically?
I don't think many companies would be willing to take the leap. Probably they would wait for some other ones to just try it, and then when it looks mature, then okay, maybe I can just jump ship. But it's something that would happen gradually.
It's also something that we run into with familiarity. Like your high performance computing folks, they know their InfiniBand inside out. Ethernet is a new player in the space for that particular application. And as you said, with companies moving to things like Fibre Channel over Ethernet, we saw how that went. That required a complete rewrite of the whole Ethernet frame to make it work properly. Interoperability was a little bit questionable at that point, where InfiniBand actually has a much more neutral platform. You want to run your storage protocols over InfiniBand, use SRP, you're done. You want to run IP over InfiniBand, that's not a problem. It takes care of that natively. Do they want to move to something that they're going to see as less suited to the task?
And I would be remiss if I didn't mention here that similar to Fibre Channel over Ethernet, the proposed solutions for running these high-performance Ethernet links through Ultra Ethernet Consortium are themselves a more or less non-standard fabric. because there's packet spraying is the term that gets used, where the packets are flung across the link and reassembled on the other side to overcome the performance issues that we ran into with standard Ethernet. Even ECMP can't keep up. And most of the testing that we've seen has shown that you need a 1.3x improvement in speed with Ethernet to equal the performance profile that you get with InfiniBand. So are we working ourselves kind of into a corner where, even though on the tin it says Ethernet, it's not really Ethernet, it's just another proprietary mesh network?
Mm-hmm. Ethernet has always been built on the principle of cheap, fast, and we don't necessarily care if we lose something. We've kind of gotten away from the we don't care if we lose something with full duplex networks and cut through fabrics and all of that kind of stuff, but that's all development of Ethernet. Cheap, fast, and mostly good has always been its mantra. I don't know how well that jibes with high performance computing. They don't like losing things.
Yeah, I think there may have to be a forcing event here, right? Because I think at some level, all the discussions around whether or not modern Ethernet can compete or can provide a reliable and functional replacement for InfiniBand is somewhat theoretical until someone tries it. And as we've talked about, there's a lot of gravity in just doing what we are used to doing and using the tools that we're used to using. Carpenters don't usually, reach for anything other than their hammer, et cetera, right? This is something that's very easy muscle memory, that InfiniBand is the answer, so that's the answer, and it goes on. Now, it may be that Ethernet with data center bridging and some other advances has moved into a position where it is a cheaper and better alternative. That's not necessarily going to make people move. However, if there were some kind of, I'm not trying to place a hex on anyone, but if NVIDIA had some, manufacturing slowdowns, or if InfiniBand became hard to get, if there was a forcing function, I think people would very quickly find that Ethernet may be a very valid replacement.
So this sounds like a similar event to what happened during pandemic when, there are still actually results of that, or consequences of that most of the vendors were not able then to keep up, and many companies or even service providers just moved towards then software switching platforms, simply because it was cheaper, it was faster, they didn't have to wait in a queue for another 1 or 2 years to get something. So then the question is, should we then expect this to happen just so that then some companies could move into the other direction? Because it's more or less what happened during pandemic in 2020. And it still happens, actually. There are still some queues of things that were not delivered. They're still recovering.
Is the cost of moving more than the cost we're saving by moving to it?
And again, in order to be fully transparent with this discussion, we have to mention the fact that there is a physical limit for InfiniBand devices. It tops out somewhere around 48,000. Because of the way that the network has to be built. And we ran into the same problem in the Fibre Channel space, because everything effectively had to be directly connected through a single switch, for lack of a better term. So that limited your scaling capabilities. And we see that in InfiniBand. So one of the, selling points, if you want to call it that, is that they can expand north of 50,000 nodes. Do you feel like that is enough of a performance gain to warrant ripping and replacing these devices?
But would you want 48,000 well-performing devices or 50,000 plus somewhat well-performing devices? You would have then to weight the pros and cons. But if your main requirement is high performance, and you do know for a fact that in some applications it might work, but not in others, Ethernet would just do what you're expecting it to do, then does it make sense for you? Then how many of those prompts that the AI is going to get are going to be lost in the moment that we have to refresh some particular thing in the switch that is running the Ethernet link for that?
And the other thing we have to consider is that, as Tom said earlier, the InfiniBand application is the GPU to GPU stuff. It's the high performance computing stuff. They're not connecting absolutely everything with InfiniBand. They're connecting the core stuff with InfiniBand. All the access stuff is going to still be Ethernet anyway. So is it going to go over 48,000 nodes on that particular application?
And one other thing that you're also going to have to think about is that what if NVIDIA decides they're not going to support InfiniBand for new feature releases as well? Because they are slowly migrating to an Ethernet-based framework. Spectrum X runs on Bluefield 3 and some other networking technologies that they've acquired. SuperNIC, I think, is the term that they're using instead of a DPU. So do you see maybe InfiniBand being pushed into a specific performance profile corner where it's like, if you're going to run a smaller deployment, fine, use InfiniBand, or fine, use Ethernet. But if you want to run big, fast workloads that have huge elephant flows, you're going to need to run InfiniBand to make sure that they work.
Yeah, I mean, one of the things here, I mean, aside from just the number of nodes and the kind of size, I think one thing that we can highlight here pretty obviously, at least in my opinion, is just flexibility in general, right? There, while InfiniBand does offer some, interesting advantages to the HPC world, or at least has historically, Ethernet offers flexibility almost always, almost everywhere. And especially now that, again, if we kind of work under the assumption that Ethernet has caught up in a lot of ways, I can certainly see Ethernet surpassing, just because it becomes that multi-use tool, right? If I'm building a massive data center and the front end, quote unquote, of everything that's facing out towards the world, my APIs, my portals, my websites, all of that stuff is all going to be Ethernet anyway, and every other network that's being built almost everywhere in the world is Ethernet, then at some point it doesn't make any sense to not build that back-end network with Ethernet, right? You mentioned Fibre Channel over Ethernet, Tom, and it definitely did not take off. But Fibre Channel has definitely not grown in that period either, at least from my experience, right? A lot of storage networks now use Ethernet because it's gotten good enough, and Fibre Channel is just more expensive. And I assume that we'll see a similar path forward in the InfiniBand space, in the AI space, and the kind of big data, even HPC in general space, where at some point it's just not going to be making sense to buy these dedicated InfiniBand cards, switches, whatever, and just, using the Ethernet that I'm using everywhere else is going to make a lot more sense from a sparing perspective, from a tooling perspective, from a knowledge of staff perspective, and just flexibility of what I can use these devices for.
It's probably going to be in the moment when it's not just a handful of players doing it or a handful of companies doing it, but it becomes more common and becomes more mainstream. Then you would have the more incentives to try to develop a common alternative that everybody can use, or at least that will be more, well, I wouldn't say simple, my apologies. That would be easier to also understand and implement, because the moment that you jump into purpose-built deployments, then you have to handle a whole unique snowflake on its own.
It kind of it's that whole has Ethernet really caught up thing, and Ethernet has caught up with a little asterisk at the end, in the sense that if you just want plain old Ethernet, yeah, speed, it's all there. But if you want lossless, okay, now you've got to be sure that you're dealing with the cut-through switching architectures. If you want Rocky to get your RDMA over Ethernet, well, that's just a little bit different than your regular Ethernet. Just like Fibre Channel over Ethernet, it's just a little bit different from your regular Ethernet. So you kind of have to weigh out those complexities and say, oh, okay, are we prepared to address our Ethernet convergence and the complexities it brings to get the same thing as InfiniBand? It's not the same thing as just plugging in a switch to replace your InfiniBand switch. And that's going to be interesting to watch.
Yeah, I would agree that this is fundamentally a shift, and what we're landing on may look like Ethernet on the outside of the box, but it's not going to perform like Ethernet, and it's not really going to be configured like Ethernet, at least at first. The hope is that some of that trickles down into the standard Ethernet protocols and makes things a whole lot easier on all of us. But again, there's no guarantee of that. And we've also seen some companies like InFabrica who are trying to reach out and even build some more ultra Ethernet optimized devices that sit in front of that cluster to help organize things like packet scheduling and better optimization of things like that. So I feel like the world is kind of at an inflection point and toss-up area that it really could be we might tweak one side of the equation and get it kind of running well, and then use that research to do other things. But I guess the other question is this only applicable to on-premises deployments, or do you feel like cloud providers are going to start embracing this? Because cloud providers don't really like to create these snowflake networks. They would much prefer to run everything on one standard kind of protocol and make it all work really well.
I mean, Tom, that could be one of these forcing functions that we talked about earlier, right? Is public cloud providers looking for homogeneity. That said, I mean, they do offer different types of processors you can select. There are some select, while they would like it to all be the same as much as possible, you can spin up a tensor cluster or things like that. And so, it's hard to scry into the crystal ball too closely as to whether or not they would offer like InfiniBand as a service. But I suspect that you're right, and that that's not going to be a thing, and that may actually be one of the things that pushes InfiniBand closer to the boneyard.
Yeah, cloud is definitely looking for more homogeneity than anybody else, because the more they can make things the same, the more profitable they can be. That's true for any service provider, really. I think for cloud, you're probably not going to see a whole lot of InfiniBand. But for the on-premises folks, what's the snowflake? Like it's all what you're used to. If InfiniBand is your standard way of doing things, Ethernet is the snowflake.
It's going to be exactly a matter of perspective. For a service provider, there is hardly anything that is not running an Ethernet unless is part of this dark and legacy piece of your network that nobody touches because it works and you just don't bother trying to fix it because it ain't broken. Other than that, everything is running an Ethernet. I haven't seen anything different for many years. I think it was a while ago, I was checking some older customer that has been running for I don't know how many years, and they had something like ATM, and I thought I came back in time just the moment I saw the output in the box. But it's a rare and fairly uncommon thing to see. Ethernet for them is just the standard. So then we're back into exactly what you mentioned earlier. It's a matter of perspective then. If you're a service provider, then yeah, it's going to be the common thing. If you're focused on building then applications and building the AI clusters, then Ethernet is going to be the weird thing for you because you're used to a completely different infrastructure.
That's going to be really interesting to watch and see how many of the big AI guys are going to go cloud. Is it going to is there going to be an attractive proposition there?
Yeah. Well, and this is another piece, right, which is for the on-premises folks, if I'm building out some kind of AI cluster based on HPC hardware, some of this is just going to come down to, does that HPC hardware come with only InfiniBand ports on it, or can I actually even order it with Ethernet? And that I think will help either, hold this back or not. Because I guess that's the other thing. As much as I've kind of, talked about the idea that Ethernet could eventually surpass and take over most of the roles that InfiniBand is in today, I also am very well aware that technologies don't tend to die almost ever. Folks are still writing COBOL. There is still Fibre Channel out there. There's Frame Relay. There's ATM. There is going to be InfiniBand for probably as long as we're alive. It's just a question of what that ratio looks like, I think.
It would be also about which vendor is gonna jump into this fight, right? Because as an example, what Cisco was trying to do in the service provider space with the optical router and working, in which they just had this, they made use of the acquisitions. I think it was Luxtera, and I forgot the other one. My apologies. And then they created this the transceiver that would do also the optical networking, and you wouldn't need then an additional box in the middle. Then the moment then you have a vendor jumping in and trying to simplify this particular changes in the medium, then that's when things could get interesting, because it's not only about the customers asking for it in the case of the cloud, but if you have a vendor that is then facilitating this type of implementation, then there you go, we got ourselves a highway, we got ourselves a way to get faster there. So it all depends.
And you do have to look at the motivation here. Like you look at the folks who are doing the Ultra Ethernet thing, and these are vendors who are seriously invested in Ethernet. Cisco got out of their InfiniBand stuff a decade or more ago. So you're saying, okay, these guys have something to offer to high performance computing. They're basing it off Ethernet. It looks really interesting. But the question we have to ask is Is it because Ethernet is really good and applicable to this application, or is it because the Ethernet vendors of the world are bothered that they're missing out on high performance computing money? Yes, in both cases, but you kind of have to take it all with a grain of salt.
Well, as you can see, the answer isn't exactly black and white. There's a lot of nuance in this. What is it going to take to unseat the current incumbent? How on earth are we going to be able to pay for all of this? Does the cloud have any input on how this is going to look? And lastly, what do you feel comfortable with? There's nothing wrong with running an old protocol that provides consistent performance. There are still industrial machines that run on ArcNet and will probably never be upgraded. Is AI a cutting-edge technology that requires cutting-edge solutions? I don't have a good answer for that. But the input that we give today on the way that the Ultra Ethernet Consortium moves forward will help us determine if InfiniBand is here to stay or Ethernet will once more become the king of the mountain. That'll just about do it for this episode of the On-Premise IT Podcast. I want to thank you all very much for tuning in. You can find the latest episode on our YouTube channel at youtube.com/GestaltIT-video. You can also subscribe in your favorite podcast application of choice. Just look for On-Premise IT Podcast. And yes, we are using On-Premise correctly there. We'll be back with another episode in a couple of weeks. So until then, stay tuned, take care of yourselves, and keep your eye out for that fancy new Ethernet.